Hey guys, today we're going to talk about what if I have a problem to solve and there's more than one operation to do. So we're going to talk about our old friend, Lesson 6-2, Order of Operations. So, oops, come on, UN. There we go. So let's talk about, first off, what kind of problems are we going to deal with? We're going to deal with something called numerical expressions. So you should probably be able to figure out what numerical means, numbers. And an expression is a problem that just has a bunch of things mathematically for us to do, order of operations, different ones, but there's nothing I can solve for. In other words, there's no equals. What I can do, though, is simplify my expression. So I call it a math phrase, because you know how in English we have phrases and we have sentences? So a phrase is just kind of a part of something. It's really not a standalone thing. And so I liken it to a math sentence would be something that has punctuation, and our punctuation in math would be an equal sign. So this one is just, we can do the math that we see, but we're not solving for a particular unknown value, okay? So it's a math phrase that contains numbers and operations, but no equal sign. So that's a biggie. So this whole chapter, I'm pretty sure, just deals with this notion of expressions. And then I think the next chapter is about equations. Okay, so let's talk about that. What is the order of operations? What does that actually mean? Now, there's a really important reason why this order of operations has come into play. Excuse me. And I'm sure you guys remember from last year, your teacher taught you a mnemonic device about order of operations that tells you what is the order you must follow. And that was PEMDAS. Okay, please excuse my dear Aunt Sally. And each of those letters stands for an operation that we have to do. But maybe what your teacher may have forgotten is that the reason why we have to follow this order is so that every person who solves this problem is going to come up with the same exact answer. So basically, the order of operations is a series of steps to solve an expression so everyone gets the same answer. Okay? So what I'm going to do is take this order of operations and I'm going to change the first letter, and I'm going to use the letter G. Okay? Now, what I'm going to do is I'm going to fill out all these letters, and we're going to go back and write down what they stand for. So G is the first one. E, for, remember PEMDAS? GEMDAS is what I'm going to call it. And then we're going to do M, D, and then last but not least, we're going to have A and S. All right, so let's go back up to the G. Now, PEMDAS, the P stood for parentheses, so it kind of gave you the idea that the only grouping symbol that we would ever see in a problem are parentheses. Now, while I agree parentheses are a grouping symbol, there's a lot more of them. So we're going to write up here, grouping symbol. Now, this is going to go out, but that's okay. So grouping symbols. So we've got our parentheses. Then we have brackets, so those are the squared off ones. Then we have braces, which look like, and I'm really bad at these, a forehead, a nose, and a chin, something like that. And then the one that people forget about is the fraction bar. It is actually a grouping symbol, and how it groups all the things in the numerator. We figure out what that answer is. It groups all the things in the denominator. We figure out that answer. And the very last thing we're going to do is divide. Okay? Now, the second guy you should be pretty familiar with because we just took some notes on him yesterday. So, speaking of which, yesterday, I forgot something like the date. 1/31/19, last day of January. So we have exponents and power. Oops, sorry. I don't know what I was writing there. They have second priority, okay? Now, the thing that really throws some kids is this multiplication division. And what kids think is, well, I always have to do all the multiplication first because it shows up first in this, please excuse my dear Aunt Sally, is what I like to call GEMDOS. But the reality is, I'm going to multiply or divide as I read from left to right. So it's not about multiplication comes first, it's about which of these two operations shows up first in the problem as I read it from left to right, and that's going to be the one I'm going to solve. Now the same idea happens with our 2 down here, where I'm going to add or subtract. Poor lowly operations. And we're going to add or subtract again as we go from left to right. Left to right. Sounds like I said rice. Oh my goodness. Now, I'll give you a little hint why this is the proper order, because if we did adding and subtracting first and then multiplication and division, we could come up with a bunch of fractions. So this is why we got to do the multiplication or division first. It just takes its priority. Now, here's something that can come up when I have grouping symbols. In grouping symbols, I may have more than one operation to solve. Okay? So guess what? In grouping symbols, you always follow the order of operations. So the order of operations take place across a problem and within any kind of grouping symbol inside the problem. Okay, so let's go ahead and do a practice. Now, one of the things you're going to see me do in this practice, we have 17 minus 5 squared divided by the quantity t plus 3, is I'm going to number the order of the steps I'm going to take. Now, the reason why I do that is just to help me track things and to get used to these, the order of operations. The G first, then E, M or D, A or S. So first thing I look for always, first and foremost, is any kind of grouping symbols. And I see some parentheses, so I'm going to be working there. But inside the parentheses, I do see an operation, which happens to be adding. So that's what I'm going to do. Okay, so inside. So this is technically one step, but not really. Okay? So what do I have? I end up with 17 minus 5 squared divided by, and then 2 plus 3 is 5. So I write all the stuff that I didn't touch, and then I replace the math I'm doing with its value, with its answer. So now I'm going to look and say, do I have any more grouping symbols? And the answer is no, I don't. So do I have any exponents? And the answer is yes, I do. So that's going to be the next thing I do. And I get 17 minus, and 5 squared is 25. So remember that sheet we put into yesterday's notes. You got to memorize your perfect squares. What do you get when you square something? Bam, you want to know the answer. Okay, so I scan through the problem, no more exponents. So then I look for any multiplication or division, and I scan through, and yep, I have some division right here, so I'm going to do that next. And I get 17 minus, and 25 divided by 5 is 5. Last but not least, it's either going to be adding or subtracting, and in our case it is subtracting, so that's our final step. And we get 17 take away 5 is 12. So notice that I did one step at a time. The other thing I want you to notice is that the broadest part to my problem was the beginning. And then as I solve, my work got more and more narrow until I solved and created basically an upside down triangle of work. That's what I need to see from you guys. One step at a time, and you don't do little things above and below. I just don't understand where kids are coming from. You do replace one problem with its value, and then you move on. You got to do this, guys. Believe me, it's going to help you down the line. All right, so let's go ahead and go down the line, and we're going to do some examples. So our directions are going to ask us to find the value of each expression. Okay, so we've got 4 plus 3 times 5. So we're going to start off kind of simply, and then we're going to go a little bit more complicated with our problems. So first thing I look for is, do I have any grouping symbols? And the answer is nope. So then I go through again and I ask, okay, do I have any exponents? And the answer is nope. Do I have any multiplication or division? And the answer is yes, I have some multiplication. So that's going to be the first step in this problem. So I get 4 plus, and then 3 times 5 is 15. Great. So then I go back. Do I have any more multiplication or division? Nope. I've got one operation. It's adding here. And so I'm going to go ahead and multiply or add. And I get 4 plus 15 is 19. So again, notice I've got that upside down triangle. This is what I want to see every time when you're doing these problems. You don't need to draw the triangle, by the way. That's just for visualization for you. All right, next problem. 16 divided by 2 times 4. Grouping symbols? Nope. Exponents? Nope. Multiplication or division? Yep. In fact, I've got both of them. So which one do I do first? Whichever one shows up first. That would be the division. So I'm going to do 16 divided by 2. That's 8. And then write out the rest of the problem. Okay. I have multiplication, so that's my second step. And I have 8 times 4 is 32. And again, you should notice, got my triangle. All right, now we're going to get really complicated. Let's do 20 divided by 4 plus 17 times the quantity 9 minus 6. Okay. Now, I'm going to not number it the way I did in the first example, because technically the grouping symbol is not the math. The grouping symbol is the location of what I'm going to do, and this problem definitely has a grouping symbol. So I'm going to mark it with a 1, because I have to do whatever's in the grouping symbol first. But I am going to do the subtraction inside the grouping symbol first. So I'm also going to number him 1. So what do I get? 20 divided by 4. Haven't done anything with these guys. Plus the 17 times, and then 9 take away 3 is, or 9 take away 6 is 3. I always do that. All right. Do I have any exponents? And the answer is nope. Do I have any multiplication or division? The answer is yep, and I got, again, two of those. So what happens first? Division. So that's going to be my second operation I'm going to perform. And I get 20 divided by 4 is 5, and then I write out the rest of the problem. Then I look for any multiplication or division, and I have a multiplication problem. Sorry, it's not a 2, that's a 3. That's the third operation I'm going to do. And then I get 5 plus, and then 17 times 3, 51. And then the only thing left for me to do is to add, so that's my fourth operation. And I get 5 plus 51 is 56. Okay, and again, I've still kept that upside down triangle shape. Okay, number 4, I have 5 plus the quantity 8 squared minus 2, oops, and then times 2. So I bet you were wondering, hey, we're doing this GEMDAS thingy, but there's no there's no there's no exponents. Well, this problem's got them. So first place to draw your attention, we actually have a grouping symbol. But in the grouping symbol, we have 2 operations happening. So I have to go through the process. So after grouping symbol, do I have any exponents? And the answer is yes. So that's the actual first operation I'm going to be doing. So I get 5 plus the quantity, and then 8 squared is 64, minus 2 times 2. Now I still have the grouping symbol, it hasn't gone away, and I have to do what's ever inside of it. So the second step, second operation, is going to be subtracting from inside that grouping symbol. So I've got 5 plus, and then 64 take away 2 is 62. So notice how the parentheses, the grouping symbol goes away after I do the math. And then I write out the rest of the problem. So then I ask myself, okay, there's no more grouping symbol, there's no more exponents, do I have any multiplication or division? And the answer is, yep, you do. So the fourth operation is going to be that multiplication, and I get 5 plus, and then 62 times 2 is 124. And then the last thing I have here is addition, so that's my fifth operation. And 5 plus 124 is 129. And again, you should see upside down triangle. Okay? Boop. All right, so I've got one more, and it's a word problem. So what I'm going to do is I'm going to write it off screen so that I don't take away so much time, and I suggest that once it pops up, pause it and write it down. Okay, so see you in just a few clicks. Okay, back again. Now you understand why I clicked off. So Alex and her 3 friends are at the mall. Each person buys a pretzel for $4, sauce for $1, and a drink for $2. Write an expression for the total, then find the total cost. All right, again, pause the video, write this down. I'll wait for you. All right, ready? Here we go. So, what we're going to do, I'm going to actually show you 2 ways to solve this problem. First off, how many people are involved in this problem? Well, according to what it says right here, there's 4 people. Okay, and then we are going to be buying for each person a pretzel. So I could show that cost as being 4 times, I'm going to use the dot this time, 4 times 4. And we're going to buy sauce, so that would be plus. And we have 4 people, and each one is going to buy a sauce that's going to cost $1. Oops, sorry, same color. That was silly. Try that again. Okay, ooh, that was, I don't know what my deal is tonight. And then they're going to also get, so that's going to be another times. Each one of the 4 is going to get a drink, and that drink is going to cost $2. Okay? So what we're going to do is that's the expression. So that would be answer number 1. So I'm going to just kind of box it. Now, do you see something that's the same for all those problems, for all those little parts? 4 times 4 plus 4 times 1 plus 4 times 2. So a secondary way to have written this problem, and maybe you already thought of it, would be I have 4, and I'm going to multiply it by all the costs of the food. So I've got $4 for the pretzel, plus $1 for the sauce, plus $2 for the drink. So what's in the parentheses is how much it costs for one person, and then I multiply by how many people are getting that. Okay? Now, I'm going to go ahead and go with the left one because I like it. It makes me do more things, and I like to do more work sometimes. Isn't that crazy? So what I notice is that I have 4 multiplication problems, and I'm going to show you a little trick. If I have problems that involve multiplication or division, and in between a multiplication or division problem, I have adding or subtracting, the answer I get from the multiplication or division problem will not affect what goes on with adding or subtracting. So let me show you what I can do here. I can do 4 times 4 is 16. Plus, I can do 4 times 1 is 4. Plus, I can do 4 times 2 is 8. So then I just keep adding, and the next thing I'm going to add is the 16 and the 4, because it's whatever comes up first between left and right. And then I get 20 plus 8 is 28. So my conclusion would be Alex and her 3 friends spent $28 on pretzel, sauce, and drinks. Okay, seems like a lot of money for pretzel, sauce, and drinks, but yeah, whatever. And I'm going to throw a word in there, and that word is going to be Sophie. That's our magic word for today, and here's the reason why. I'm looking at my little black cat, Sophie, is on the bed with me, and she's getting ready to go night-night, as am I. You guys have a great night, and I'll see you later. Bye.